Today's lesson is 7.1, Parallelograms and Rectangles. As we go in to start this unit on polygons and quadrilaterals, before we start talking about parallelograms, let's go ahead and talk about our how to find our interior and our exterior angles of any polygon. All right, so when I take a side and I extend it, I can create two types of angles. I can create this angle, which is called exterior because it is outside of my polygon, and this angle, which is considered interior because it is inside my polygon. Now, what we started to notice is that if I were to take a vertex of my polygon and I were to create all the triangles inside, so from one to another, from one vertex to another, creating triangles, I could figure out the sum of the interior. Now a triangle we know adds up to 180 degrees. So what we started to notice is that the sum of my interior angles, this plus this plus this plus this plus this, is going to be equal to n minus 2, where n is my number of sides, and this n minus 2 is the number of triangular regions that I have, times 180. Okay, so to find the sum of those interior angles, I'm going to do the number of sides minus 2 times 180. If I want to find each one, I'm going to do n minus 2 times 180, and I'm simply going to go ahead and divide by n, my number of sides. My exterior angles, the sum of my exterior angles for every single polygon that ever existed from a triangle to a hundredgon, is 360 degrees because I'm going to go around that polygon in a circle. So 360 degrees. If I want to find each of my exterior angles, I'm simply going to take 360 and I'm going to divide it by n, the number of sides. Let's go ahead and take a look at a problem we could see. So here is my example, and they want me to find x. The first thing I need to do is I need to know what n equals. So I simply need to count my number of sides. 1, 2, 3, 4, 5. N equals 5. Now, I wasn't using those marks as congruents. I was using them just to help me count, right? 1, 2, 3, 4, 5. All right, now I'm going to go ahead and I'm going to plug it into the formula n minus 2 times 180. So 5 minus 2 times 180. Or I could go ahead and do 3 times 180. Either way, I get 540 degrees. If I were to add up all the angles in this polygon, plus 147 plus x, they would have to equal 540 degrees. So I'm going to go ahead and I'm going to combine together all those numbers, and I end up with 469 plus x, and I simply subtract the 469 from each side, leaving me with x is equal to 71 degrees. Okay? All right, let's go ahead and talk about a special type of quadrilateral called a parallelogram. A parallelogram is a quadrilateral, which means it has 4 sides, with both pairs of my opposite sides are parallel. A parallelogram has 5 distinct properties, and your quadrilateral must meet all 5 of these to be classified as a parallelogram. All right, the opposite sides are parallel, and this is the symbol for parallel. I know it's been a while. Therefore, they have the same slope. How I mark parallel in a picture is with little triangles like this, little arrows. Sometimes you see full triangles, but there you go. My opposite sides are also congruent. Congruent. Here is the symbol for congruent, which means they are the same. So this AB is equal to CD and BC is equal to AD. Okay, I don't have to tell you they're equal. If I tell you that ABCD is a parallelogram, then the properties all hold true. The opposite angles are congruent, which means they are also equal. So angle A is equal to angle C, and angle B is equal to angle D. My consecutive angles are supplementary. Ooh, there's one we haven't heard in a while. Mentary, which means angle A plus angle B equals 180 degrees. Angle D plus angle C equals 180 degrees. It also means angle A plus angle D equals 180 degrees. And it also means angle C plus angle B equals 180 degrees. Okay, so consecutive means they've got to make a straight line. So here, those two, or here, those two. Same thing. Here, these two angles, or here, those two angles. They've got to make a straight line with one another. My diagonals, of course, my diagonals are, I've got to pick another color, you guys. Oh, how about that one? They bisect each other, which means they cut each other in half. Okay, I don't know why my diagonals are not there. Let me add in my diagonals. Oh my goodness. There's a diagonal, there's a diagonal, and they are bisecting one another, so they're cutting each other in half. Notice that I did not say that they were equal to each other. So this part and this part are the same, but this part and this part are equal to each other, but not to the other two pieces. So this one and this one, not the same, not the same. All right, let's go ahead and take a look at our first example. Here is our parallelogram. Let's find the values of M, N, and X. M, N, and X. All right, so I see some stuff written in. I see some angles. I'm going to grab my angles. Okay, but those two angles are not equal to each other. I can tell because of the arc marks. One has 1, one has 2. P would be the same as R, and Q would be the same as S, right? Because the definition says, the properties say that the opposites are congruent. So that's not going to help. I'm going to have to find a different one. I also can see that I have diagonals in here. So this is the same as that, and this is the same as that. There we go. That's where I'm going to start. So I'm going to start with finding M. 3M is equal to 15. They are both part of my diagonal, and they are equal to each other by the properties. I just have to divide both sides by 3. M equals 5. There's my first answer. Yay! I'm going to go ahead and find N next. I'm going to go ahead and find N next. N is here and here. They are also part of the diagonals, and the property says that they bisect each other, so the two pieces are equal. So 2n equals 12 minus n. I'm going to add this n to both sides because remember, you want to do, right? You want to watch your equal sign. And 2n plus n would give me 3n equals to 12. Divide both sides by 3. N equals 4. There's my second one. And let's see, X. Now, I left X for last, partially because that's the order they had here, and partially because I wasn't quite sure what to do. But then I remembered that when I looked through my properties, it said consecutive angles are supplementary, which means because these two angles form a straight line together, they add up to 180 degrees. So 5x plus 1, I'm going to have to distribute, plus 2x is going to give me 180 degrees. Let's go ahead and distribute that. I don't know why I didn't distribute it. It wasn't distributed already. There we go. Next, I'm going to go ahead and combine together my like terms, 5x and 2x. They are on the same side of my equal sign, so I can go ahead and add them together. That would give me 7x plus 5. I'm going to go ahead and subtract the 5 from both sides, leaving me with 7x equals, oops, I was thinking of what's on the next side. 7x equals 175. And I'm going to go ahead and divide by 7. X equals 25. Now, if I needed to, if I were asked to, I was not. But if I were, I could go back and plug in my answers. I could come back up here. 3 times 5 is 15. I could come back here. 2 times 4 is 8. 12 minus 4 is 8. And then I could add these two pieces together to find how long this is. 8 plus 8 is 16. I could come back here and plug it in. 2 times 25 is 50, and I could come back over here and do it as well, whatever 5 times 26 is. All right, we have one more quadrilateral to talk about today, and that is a special type of parallelogram called a rectangle. A rectangle is a parallelogram with 4 right angles. Now, what I'd like you to notice as we look at the properties of the rectangle, notice that these last two properties has stars next to them. That's because properties 1 through 5 are the properties that make this quadrilateral a parallelogram. These last two properties, 6 and 7, are the ones that specifically make it a rectangle. So a rectangle is a parallelogram, but it's a special type of parallelogram. So let's go back and let's go through. The opposite sides are parallel, just like in the parallelogram. So the top is parallel to the bottom, the left side is parallel to the right side. The opposite sides are also congruent, which means that they are equal. So once again, the top is equal to the bottom, the left side is equal to the right side. The opposite angles are also congruent. Okay, A and C are the same. B and D are the same. My consecutive angles are supplementary. So A plus B is 180 degrees. B plus C is 180 degrees. C plus D is 180 degrees. And D plus A is 180 degrees. My diagonals are going to go ahead and bisect each other once again. Okay? Now I'm going to wait to mark that one because I have two new properties that make this parallelogram become a rectangle. I have 4 right angles, which are 90 degrees, of course. So angle A, angle B, angle D, and angle C are all 90 degrees. Okay? And my diagonals, not only do they bisect each other, but they are congruent. They are congruent. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Every little piece is the same. All right, let's go ahead and take a look at our example. Let's go ahead and take a look at our example. Quadrilateral QRST is a rectangle. QS is 3x minus 2, and RT is 48 minus 2x. I'm going to use my colors, and my colors are not really, I'm going to use the two colors that I have, the pink and the blue, and I'm just going to use them to help me to identify QS. So I'm just going to go ahead and trace it, okay, and then RT. Okay, well, they're my two diagonals. And what we learned is that they are congruent. So QS is equal to RT. We just saw that. So I'm going to go ahead and say 3x minus 2 equals 48 minus 2x. Draw my line and let's solve for x. Let's add the 2x, which gives me 5x minus 2 equals 48. I'm going to add the 2 to both sides, which gives me 5x equals 50. And I'm going to divide by 5. X equals 10. I could go back and plug those in and solve if I needed to, but I was not asked to.